So next up on our adventures about learning about the mole is the topic of molar mass. Now, you may recall that when we started talking about what is a mole, that there was a very special number that came into play quite often, and this was the average atomic mass. We found that when we put this average atomic mass for an element on the balance in grams, and we started counting the number of atoms, we always came up with the same number, 6.022 times 10 to the 23rd. So with this particular example, with beryllium, if I would actually mass out 9.012 grams of beryllium and put it onto the balance, I would be guaranteed to have 6.022 times 10 to the 23rd atoms. Now, what's very important to realize again is that this number, this 6.022 times 10 to the 23rd, is just a big number, and this big number has a name, 1 mole. So it will be just absolutely fine now to replace the 6.022 times 10 to the 23rd, which is a mouthful, with the much simpler 1 mole. So let's just take that number and swap it out. And now the statement is still true. If I mass out 9.012 grams of beryllium on the top of the balance, I will actually have 1 mole of that material. This is actually what we would determine to be molar mass. Molar mass officially is the mass of 1 mole of any substance. And if you want to find out what the molar mass of a substance is, it's very simple. It's the same thing as the average atomic mass. So 1 mole of a substance will always equal the average atomic mass in grams. Let's work through a couple examples. First of all, what's the molar mass of carbon? Well, you don't have to look too much further than the periodic table. So here is the element tile from the periodic table. And again, I'm just going to be looking at the average atomic mass, 12.011. So I can actually now make the statement that 1 mole of carbon is equal to 12.011 grams of carbon. So if I would want to measure out 1 mole of carbon, I would have to go and fetch 12.011 grams of it. Try this one out. What's the molar mass of chlorine? Well, find the tile for chlorine on the periodic table and specifically look at the average atomic mass, 35.453. That means that 1 mole of chlorine is equal to 35.453 grams of chlorine. And now notice how I'm consistently writing that out as an equivalent statement. This equals that. 1 mole equals this number of grams. That's going to be incredibly crucial for later on. You might want to practice writing that out yourself as well. Well, let's take a look at this more complicated problem now. What is the molar mass of carbon tetrachloride? Well, we have a pretty big problem. I don't know about you, but the last time that I looked at the periodic table, I didn't see carbon tetrachloride in any single tile. So what do? Well, it's kind of important to note that carbon tetrachloride is just made of carbon and chlorine, and both of those are found on the periodic table. So maybe I can find the molar mass by using a little bit of math. Okay, so let's figure out what this math might look like. Now, the first big step to do with any single problem that's dealing with a whole molecule, a whole compound, is to write out its chemical formula. In this case, it would be CCl4. Now, what does that really mean? Well, that means that this compound is made of 1 carbon and 4 chlorine atoms. So when I go to look up numbers from the periodic table, I better pull 1 carbon and 4 chlorines off of the periodic table. And here they are. So 1 carbon, 4 chlorines. Now, what do I do with all of this information? Well, just add it up. So simply add up the average atomic masses of each one of these elements, and that will get you to your average atomic mass. In this case, it's 153.823 grams. So again, you could make the statement that 1 mole of carbon tetrachloride will weigh, or I should say have the mass of, 153.823 grams. Let's try another problem. How about what is the molar mass of ammonium phosphide? Well, again, start with that chemical formula. In this case, it's NH4 in parentheses 3, P. Okay. Well, what does that mean? Need to remember that the subscript outside of a parentheses essentially will distribute inside the parentheses. We don't distribute it when we're writing the chemical formula, but when we're going to be doing the math with this chemical formula, it's important to distribute it. So essentially what that leaves us with 3 nitrogen atoms, 12 hydrogen atoms, and 1 phosphorus atom. Now let's look up those masses from the periodic table. Here are the 3 tiles. Honestly, if I added in the 3 and the 12 and the 1 to put all of these tiles on the screen, I wouldn't have enough space. So I'm going to kind of condense this a little bit. Well, what that is really going to mean that I need to do is, since I have 3 nitrogen atoms, I need to add in the mass of nitrogen 3 times. So I'm going to take 3 times 14. And actually, I'm just going to do that for each individual element. Since I have 12 hydrogens, I'm going to take 12 times the mass of 1.008. And since I only have 1 phosphorus, I'm going to take 1 times the mass of 30.974. And at the end of the day, then I just need to add them up. In this case, I get the final answer of 85.091 grams. And again, very important to, at the end, to be able to write down the equivalence statement. Something equals something. And in this case, 1 mole equals 85.091 grams. So one more time, molar mass is the mass of 1 mole of a substance.